online classes of SHIVAJI group of institution. Student, myself Jitendra Tripathi. Student, in previous class we are starting a new chapter, hydrogen, and there are some periodic position and occurrence, and also some methods of preparation of the hydrogen gas. Now today remaining preparation reaction present here. Next one is the by the action of dilute H2SO4 or HCl on metal. This one is the second reaction by the action of dilute H2SO4 or dilute HCl on metals. It means we take dilute acid H2SO4 or dilute HCl on metal. Metal like magnesium, aluminium, zinc, iron. Which one metal? Metals like aluminium, magnesium, aluminium, zinc, and iron. These metals react with the following acid like dilute H2SO4 and dilute HCl react with to form corresponding metal salt and with the evolution of hydrogen gas. First we take magnesium metal. In general way metal like magnesium react with dilute HCl. Okay. Then what happened? 2 moles of dilute gives MgCl2 with the evolution of hydrogen gas. Or if magnesium react with dilute H2SO4, then reaction proceed in such a manner as magnesium sulfate with the evolution of hydrogen gas. Okay. Now we take aluminium with dilute HCl. Just 3 moles of HCl gives AlCl3 with the removal of 3 by 2 H2 gas. Due to balancing, we take 3 by 2 or multiply by 2 in whole reaction, we give whole number reaction. Okay. Similarly, for aluminium, react with dilute H2SO4. In this case, 2 moles of aluminium react with 3 moles of H2SO4 to get Al2SO4 whole thrice with the removal of 3 hydrogen gas. Okay. Zinc react with dilute HCl. This reaction gives ZnCl2 and hydrogen gas. Or zinc react with dilute H2SO4. This gives ZnSO4 and hydrogen gas. Any problem? Similarly for the iron also form ferrous sulfate. Iron first of all react with dilute HCl to get ferrous chloride with the removal of hydrogen gas, or iron react with dilute H2SO4 to give ferrous sulfate, that is FeSO4, with the removal of hydrogen gas. Okay, this is reaction with talluride acid on metal. Now, next one is next reaction is the by the action of caustic alkali on metal. Third one is the by the action of caustic alkali. Here we take some acid. Now we take caustic alkali on metals. Okay. On metals. Acid react with metal to evolve hydrogen gas, and also metal react base or alkali react with metal also evolve the hydrogen gas. So here we take metal like aluminium, zinc and lead. Metals like aluminium, zinc and lead, okay, react with alkali like NaOH or KOH upon boiling to evolve the corresponding hydrogen gas with the removal of some metal salt. This reaction we take first of all aluminium. React with alkali like NaOH. Okay, I think this reaction studied in previous lecture, chapter 1. So, what happened? 2 aluminium react with 2 NaOH with 2 moles of water gives 2 NaAlO2. This is sodium meta-aluminate. Sodium meta-aluminate, okay, and removal of some hydrogen. How much? 2 and 4 with the 3 hydrogen gas. Okay, excess of alkali. These are amphoteric metal react with excess of alkali to evolve corresponding metal salt and with the evolution of hydrogen gas. Yes. Now we take zinc. Zn react with NaOH. Okay. Which reaction is performed? Zinc react with NaOH. That is 2 NaOH gives Na2 ZnO2. That is sodium zincite. This is sodium zincate. Sodium zincate, and with the evolution of hydrogen gas. And for lead is sodium plumbite, Na2PbO2 again. Similarly, Pb plus 2 NaOH to get Na2PbO2 with the evolution of hydrogen gas. Sodium plumbate. Okay, sodium plumbate. This is for the reaction of plastic alkali on metal. Okay. Now, fourth one is the lab method. It means how you prepare hydrogen gas in lab. So this one is a unique. Fourth one is the lab method. Lab method. Here, zinc granules means granulated zincs with sharp edge and react with dilute H2SO4 zinc granules existing in solid state, small pieces of zinc react with H2SO4 to give ZnSO4 with the evolution of hydrogen gas. Okay? By this reaction, you have to prepare hydrogen gas in laboratory, but in lab preparation there are a lot of precautions takes place, or some procedure which one is adopted, and why we take zinc granules. Reason for taking the zinc granules is also needed for you. First of all, we have to go for the precaution procedure. How will you prepare hydrogen gas in laboratory? First of all, you have to take a conical flask and take some pieces of zinc granules in it. Okay. Now set up the whole apparatus by which you have to prepare hydrogen gas and add dilute sulfuric acid with the help of thistle funnel. With the help of funnel you have to add H2SO4. When reaction starts with the brisk effervescence, reaction takes place with the formation of hydrogen gas and collected over the downward displacement of water. In a test tube, water is filled up. You must be enter the hydrogen gas in such a manner. As the hydrogen gas enter, level of water is down towards the bottom side. Okay. Now, why we take zinc granules? Reason for using the zinc granules: zinc granules contain copper as an impurity. Here we don't show the copper which is present as an impurity, but in zinc granules some copper present as an impurity. That copper speed up the reaction due to large surface area, so that hydrogen gas evolve speedily. Now, other metal like sodium, potassium, calcium, magnesium, why we don't take these metals? These are costly, okay, expensive, okay, and evolution of hydrogen gas is too much fast. That's why we don't collect it such gas in a gas jar. So we don't use calcium, magnesium, sodium, potassium. Okay. Aluminium, why we don't take aluminium? Aluminium coated with a protective layer of aluminium oxide, that is alumina, Al2O3, which does not allow the acid reaction. Further acid reaction is not possible due to protective layer upon aluminium. And iron also gives us some time slow reaction due to presence of H2S gas from hydrogen sulfur dioxide gas. Similarly for the lead, these metals are not used in laboratory to prepare the hydrogen gas. Now we take some precautions. Which type of precaution? Apparatus must be airtight. First of all, apparatus must be airtight. Allow the first bubble of hydrogen gas to escape, starting hydrogen gas escape in the air. Then you have to collect it in a gas jar, and do not bring any flame near the apparatus. Reason behind, hydrogen is too much combustible, which casts the fire, and this one is a hazard in nature. So you must be Mentally prepare for that. There is no any naked flame near the apparatus. Okay. Now, the lower end of the thistle funnel must be dipped in the dilute sulfuric acid. Means thistle funnel, which it must be bottom side at the conical flask, due to otherwise gas will escape from the thistle funnel. Reason when in a conical flask, when hydrogen gas is involved, then pass through the thistle funnel. So you have to must be take some type of some precautions. Here some impurities are also present with the evolution of hydrogen gas, like arsine gas, phosphine gas, H2S gas, sulfur dioxide, carbon dioxide, nitrogen oxide, and water vapor. These impurities are removed. Reason for that, disagreeable odor of hydrogen gas. So you must be remove such impurity with the help of silver nitrate solution. Silver nitrate solution remove the impurity of arsine ASH3 and phosphine PH3. And lead nitrate solution remove the impurity of H2S, hydrogen sulfide gas. Similarly, potassium hydroxide, that is alkali in nature, remove the impurity of acidic nature gas. Which one is acidic nature gas? NO2, CO2 and SO2. These acidic nature gas removed with the help of potassium hydroxide. And anhydrous calcium chloride, that is anhydrous CaCl2, which is hygroscopic in nature, absorb whole the water. So dried and pure hydrogen gas collected over the evacuated flask. Okay, this is all about lab method. So you must be represent all the things in your copy with the help of diagram. Okay, this is all about today. Best of luck for attending.